Good afternoon, everyone. Thank you for joining us. My name is Bill Johnson. I have the title of Carpe Geo Evangelist here at AppGeo. That title speaks to the concept of seizing opportunities to do great things with GIS. And I'd like to think that these imagery content programs that we're going to talk to you about today are one of those opportunities for you to consider. I'm joined by my AppGeo colleague, David Breeding. He's our Director of Analytics. And we also have Jarlath O'Neill Dunn, who directs the Spatial Analysis Lab at the University of Vermont. So for those of you not already acquainted with AppGeo, we just have this one brief introductory slide. We're a GIS firm based in Boston, Massachusetts, founded in 1991. All we do is GIS, and we do all of it. We do data development, application development, geoanalytics, consulting of all flavors, technology assessments, particularly on the fit of GIS and integration with other technologies. We do strategic and business planning and return on investment studies. We're not a single stack technology company. We work with a wide range of tech, both commercial and open source, and some that we've developed ourselves. For today's content, it's worth mentioning we have business partnerships with both Google and Hexagon. Hexagon, as you probably are aware, is one of the firms that's in the content business for imagery, and Google had been previously. We've been working with a number of states for the past several years on imagery content programs, both in helping them evaluate and helping them deploy. And as a result of that experience, we developed a piece of software we call Giza that you'll learn about a little more later in this presentation. So here's what we're going to cover today. We have three sections. I'm going to do the first section, basically addressing the why you should care about content programs. Then we're going to turn it over to David Breeding, who will talk to you about efficient streaming of imagery data from the cloud. And finally, we're going to have Jarlath O'Neill Dunn from UVM talk about how you can mine value from the imagery. Jarlath has done some really interesting work with his group at UVM, marrying expert systems and machine learning and traditional photochrometric methods, and I think you'll find that quite interesting. As Bridget mentioned, we're going to answer all the questions at the end. We won't be answering them in real time during the presentation, but please be sure and put your questions in the chat box, and we will stay on as long as we need to at the end to get to them all. David? So this first section, I want to just spend a little bit of time talking about the imagery marketplace and how these imagery content programs have emerged and what that might mean for you. So you'll notice the title to our presentation today had the word Renaissance in that, and we did that quite deliberately. Renaissance, as you probably know, is a French word meaning rebirth. It's usually thought about in the context of the re-emergence, the rebirth of arts in Europe after the end of the Middle Ages. But we think it's a nice parallel to what's happening in the imagery marketplace. You might not realize it, but we've actually had aerial imagery has been with us for more than 100 years. Not long after the Wright brothers started the era of flight in 1903, someone brought a camera up in the sky with them. And the first really large-scale use of aerial imagery was during World War I. And since then, from then to the present, there's been a steady incremental set of improvements in aircraft, in cameras, in photogrammetric methods, in the conversion from analog to digital, and so on. And the advent of conversion to digital made it possible to marry imagery with GIS, and that started to happen significantly in the 1990s. And now imagery is a ubiquitous part of GIS. In fact, it's hard to imagine a GIS application that doesn't use imagery at some level. Traditionally, author imagery has been costly to produce, and that's meant that for most of the past era, governments have been the primary funding source for the production of aerial imagery, orthorectified. At the federal level, and I'm speaking here about the civilian federal level, I guess it's worth pausing for a moment to note that virtually all the advances that have happened in aerial imagery and photogrammetry have their origins in the defense sector and have been gradually declassified for civilian use. So we'll say nothing further about that. But on the civilian side, The U.S. Geological Survey and the U.S. Department of Agriculture have been the two prime federal agencies behind nationwide imagery programs. There's been some participation also by Department of Homeland Security with their 133 Cities initiative. But in the main, the nationwide imagery programs have been at a lower resolution than most people at the state and local level want. And so the production of high-res imagery, which I'm defining here as a 1 foot ground sample distance or higher resolution, that's been primarily a state-led activity. And so states have started these programs to create a funding model, generally with partner agencies and local governments participating to come up with the funds to produce high-res imagery. All that has changed starting about a decade ago, more or less, with the emergence of these large internet companies that have been vying to get eyeballs on their sites. And this has been a disruptor to the traditional author imagery business. If we can advance, David. So let me dig a little bit deeper on that. So before the internet giants got involved, access to these aerial imagery was primarily on government-sponsored sites, either as downloadable data or accessible on a viewer application, such as you might have on a state GIS clearinghouse website. And that changed when the internet companies started realizing how popular and important mapping was for their online applications. And it didn't take them long to realize that this was an extremely important use of online technology. And so there has been a resulting arms race of these companies to build better and more functional mapping capabilities, all freely available to the public. And those capabilities include not just vanilla mapping functions, but also include imagery, which has also proven quite popular. And we have a new kind of a value exchange that emerged with these companies as well. So rather than paying to access this data with a paywall, they've learned that what's important is to get you on their site and for you to leave your digital footprints. And that has been extremely valuable to them to drive advertising revenues. And so what this has resulted in is large investments by these big internet companies to create vast collections of mapping data, including high resolution imagery data that they keep refreshed on an aggressive cycle. And this has changed the dynamics in the market. But before we dive into that a little deeper, I want to pause again and just say that this isn't driven entirely by the big internet companies, although I think that's the principal engine of change. We're also seeing, for example, property insurance companies have banded together to create a consortium to acquire high-resolution imagery, and all over the world, governments have a growing demand for imagery data for both civilian and defense purposes. So what's going on in the market? Well, I guess we start by saying that the traditional photogrammetric firms that have been with us for a long time are all still there, continuing to do well. The biggest change over the period of time we're talking about has been mergers and acquisitions to create larger companies so that they can capture economies of scale and compete more aggressively. But we're also seeing the demand for imagery has brought new players into the market, new companies offering a variety of imagery products. We're seeing in the satellite space companies like Planet that have launched a large constellation of small satellites, and they're collecting pixels of the entire planet every day. And there's a Chinese counterpart company competing with them with very similar capabilities. We also see a number of firms targeting the rich market in urban areas. As we become a more urban society, a lot of our cities are growing, and imagery targeted to these areas is an important way of understanding the growth and where it's happening and the impacts of that growth. So companies like Nearmap, their business model is to collect imagery 2 to 3 times a year so that you can monitor change more easily. And we also see a growing market for oblique imagery. This started mostly with a company called Pictometry, which is now EagleView. And now there are multiple companies offering similar oblique imagery. And across the spectrum, we're seeing a race to go to higher and higher resolutions. EagleView has recently announced that they're starting to collect the obliques at up to 3/4 of an inch resolution. And Hexagon announced at the NISJIC conference a couple of months ago that their program for the US is moving to entirely 15 centimeters, that's 6-inch resolution as the standard product. Now, all that's very interesting, but I think the most interesting part of this change in the market dynamic, and the part that's most important for these content programs, is that some of these companies have a major first instance buyer. And that could be a large internet company, it could be a consortium of insurance companies, it could be a government defense market, or it could be a government civilian federal buyer. Whatever the case may be, that presence of a first instance buyer is allowing them to resell that same data, resell those same pixels to other buyers at pricing that's well below the cost of collection. If you could move, David, thank you. So what are we talking about here? Well, in the traditional imagery contracting world, you would issue an RFP and hire a firm to perform the services of developing orthos for you. This is the legal term for this is a work for hire. And in a work for hire, the company is going to produce the ortho imagery to your specifications and deliver it to you. You own it, you control it, you do it with it what you want. The company retains nothing. The value exchange is the contract payment that they get for producing it for you. So you pay the full cost to generate that imagery plus the profit margin that the company included in their pricing when they bid it for you. In a content program, it's different. In a content program, the imagery company has retained ownership of the data and grants usage rights to you through a license. And so this may sound at first blush like you're giving up a lot if you're giving up ownership, but let's talk about some similar things that you're probably already doing. Virtually all software that you might use, whether it's the Microsoft Office suite or Quicken for home finance or Photoshop for editing your photos, that software is not owned by you. When you buy software, you're actually buying a license to use it, and you have no ownership of that software. And it's been like that for a long time in the software business. About 1/3 of all cars leaving the showroom these days are done under a lease. And in a lease, you don't own the car. The leasing company owns the car. The leasing company grants you a right to use that car for the 2 or 3 year term of the lease, at which time you have to give it back. And that car feels like yours. It drives like yours. It needs as if you own it. You might even tell your friends you own it. But in fact, you don't own it. But you've been willing to trade off the legality of ownership to save a lot of money, because the monthly payment is way less on a lease than for that same vehicle for you to own it outright. So you've made a decision about it's worth it to you to yield the legality of ownership to save that money. But we see in GIS software market that a lot of GIS software now comes bundled with some existing data sets. By and large, those come from other sources, other companies that have worked deals with the software vendor to include it so that you get a valuable bundle of software with data to put it into use. All of that data that comes bundled with your software is granted to you under a license. So that's quite comparable to what we're talking about in content program, where you're using GIS data under a license. And then I think what everyone understands is in the entertainment world, as a society, we've been quite willing to switch to using these online subscription services like Netflix and Spotify. Just to pick on Spotify for a moment, when you subscribe to Spotify, you don't buy any music. You don't own any of that music. Spotify has negotiated with artists and recording companies to amass a huge library of music, and your subscription to Spotify is a license to access that library. And Spotify is continuing to add to it, so you don't have to go out and buy the latest from your favorite artist. It's going to pop up in Spotify automatically. So let's move on. So if you're a GIS state coordinator or a geographic information officer or someone else, in the driver's seat for your state, I have a prediction for you. I predict that you will switch from custom collection of orthoimagery to a content program. And in my mind, it's not a question of if you're going to switch, it's a question of when you'll switch. Why do I make this prediction? Well, what we're seeing is it's going to get harder and harder to justify the substantially higher cost of a custom collection, particularly when you consider the fact that the public already has access to higher resolution imagery through all these big internet company mapping sites. And I think it's worth considering as well that the cost of your imagery program is not just the cost of your custom collection contract, although that's typically how you think about the cost of your imagery program. Is you've issued an RFP and you've awarded a contract, and that value is what you might be telling folks is what it costs for your program. But you have some other costs of the program to run that program and to manage that data. And it starts with the RFP process, which is a long, slow process and involves the participation of a number of different people. Once you've got a contract in place, you now have to manage the flow of that data coming into you. You have to have processes to verify it and accept it for payment and then make those payments to your contractor. You have to store the data. You have to tile it for delivery to your users. You have to prepare download bundles. You load it into an imagery database. You catalog it. All of these things that you have to do don't happen for free. You're using people on your team whose time you're paying for, and the tools that they're using and the systems that they operate all cost. They have a cost associated with it, and those are often not shown. And I think they represent a hidden cost in your imagery program. And the flip side of those hidden costs is opportunity costs. If those members of your team weren't doing that back-end processing work on your custom collection program, what higher value work could they be doing? How else could you be putting those resources to good use? And these are not easy questions, but I think they're important and vital questions. So we're already seeing, I'm talking about this as if it's brand new, but this is actually been going on for a few years now. And we are aware of at least 10 states that have already made the switch to an imagery content program on a statewide basis. There may be a couple of others that we're just not aware of, but we think this trend is going to not only continue, we think it's going to accelerate. And why is that? Well, first of all, these companies that are competing in the imagery content space are eager to grow their market share. So they're competing aggressively against one another. And that competition is very healthy for you as a buyer, because that competition not only forces aggressive pricing, but it also has the companies vying for licensing terms that are more favorable to you and vying for better data quality in ways like higher levels of spatial accuracy or inclusion of the infrared band, just to cite two examples. And then also particularly on refresh cycles, that is how quickly they're going to be flying new imagery over the area that you're interested in. And so we think these trends are going to continue. The companies are going to continue to differentiate themselves and improve the products. And the rationale for you to continue to do a custom collect at substantially higher cost is going to continue to shrink. And we think we see this coming to a tipping point where for most, I'll just say vanilla uses of imagery, it will not be really viable to do a custom collection. It will be, you would consider custom collection mainly for specialty requirements. And I want to go off script here and just kind of play out for you. If you're the decision maker in your state on imagery, that is, if you're the state GIS coordinator or the GIO or whatever title you might have, I want to give you two hypothetical conversations about this tipping point. So conversation one, and these are fictional, by the way. Conversation number one, you run into the budget person in your agency who tells you that they've just come from the National Association of State Budget Examiners Conference. There is such an association, by the way, and been talking to his colleagues in some other states and learned about a way to save large amounts of money by licensing the imagery rather than procuring it under a work for hire contract, and wondering why you haven't switched to that and why you haven't harvested those savings. Conversation number two, perhaps you go to this same state budget officer and say, I have an idea for you. We can meet all the requirements for our imagery at significantly lower cost, and I'd like to propose that we apply those savings and redirect them toward collecting more high-resolution LiDAR data so that we can be analyzing the high-risk areas we have for flooding and coastal storms now that we seem to be getting more and more of these severe storms. How about you and I take this idea together to the governor's office and propose a no-cost shift to a more high-value program? Now, I don't know about you, but I know which one of those conversations I'd rather be part of. Next slide, please. So we're not going to queue up Blue Oyster Cult here, and we aren't talking about custom collection going away. I think custom collection will continue to be with us. I think it's just going to become a more specialized thing. But really, you have some exciting new options with content programs. And because of the intense competition in the market, it really puts you in the driver's seat to be a winner. You're going to spend much less, probably on the order of half, to get equivalent data under a content program. You're going to be able to free up people on your team that are doing a lot of the back-end work that's done for you under a content program. And your users are going to get probably data at least as good and maybe better than what you're able to afford under your custom collection program. The resolution keeps getting better and better under these content programs. As we just mentioned about Hexagon, they're moving to 15 centimeter as the standard product going forward. And the frequency of updates is likely as high or higher than what you're able to afford under a custom collection contract. And the delivery mechanisms that are available may be better than what you can do off of your own on-premises infrastructure. David? So I want to say at this point, we've heard from many of you that there are two reasons when you start thinking about content programs that give you pause. And those are public domain access and leaf-off imagery. So I want to address those briefly here. First, with the public domain access, I think you have to realize that the licensing under these content programs does allow full public access. I want to distinguish that from being able to download. And so the question becomes, do you really have a requirement for the public to be able to download that data? And if so, is it worth you spending a whole lot more to get that download? And how much are you really willing to pay to get that download? If you do determine that it is a firm requirement for you, I would suggest to you that you can negotiate with a content provider, perhaps for a downsampled version, say 6-inch data resampled to 12-inch as a downloadable product, or perhaps the previous version of data that might be refreshed every 2 to 3 years. You could have the second newest version available as a download. So those options exist for you. On leaf-off is a challenge, and the main reason it's a challenge is that the collection period for leaf-off is so much shorter than for leaf-on. But I do offer this. Almost all the imagery that you see on these large internet mapping company sites are leaf-on. And so there's already high acceptance among a large number of users for leaf-on imagery. And we recognize that leaf-off does not satisfy all use cases, and that you may very well have use cases that require leaf-off. In that case, I offer these points. First off, we think the long-term forecast for leaf-off is good. These companies in the content space are responsive to market demand and are looking for ways to differentiate themselves. And I think over time, if the demand for leaf-off is there, some of these companies will fill that market niche with leaf-off data as a standard content program offering. That's me prognosticating. For now, you do have the option of at least proposing to a content company that you may be able to negotiate a collection of leaf-off. This would not be at their standard price for their what I'll say is the vanilla program, but you may find that the content program company is willing to acquire leaf-off to meet your requirements, and you could still save substantially over doing a custom collection at full cost to you. And the last point I'll make here is that your older imagery for leaf off makes a nice complement to a newer leaf on, and you can flip back and forth between the two. Before we get off this slide, back just for a second, there are sometimes questions about other things like derivative products. You might want to use the original stereo pairs to update your planimetrics, or have a copy for archive, or other things. I would suggest to you that you speak to your content company about these, because they're very likely to be negotiable at some level. You can go ahead now, David. So thank you. So the bottom line is, we think these content programs are a major win. We think they're going to grow, continue to grow in popularity. We think they're going to continue to grow in sophistication of the imagery, being higher and higher resolution, and more of the capabilities that meet your requirements. It's really a buyer's market, and we think there's very high upsides. The downsides, as we've talked about with leaf on, for example, versus leaf off, there are ways that you can deal with that. We think because this switch is inevitable, that the sooner you get serious about making this switch, the sooner you can start harvesting those savings, the sooner you can start readjusting the priorities of what you're doing in your program, shifting those resources to other high-value data, other high-value work. And really, I think of custom collection as rooted in an older era of state GIS coordination, when there wasn't an option, when the only way to get high-resolution orthos was to do this custom collection work. I'm calling that era the V1.0 world. Those conditions that created the V1.0 world are gone. We've gradually shifted over to a new world that I'm calling the V2.0 world. And I really see imagery content programs as being part of that. And I hope you see that too. And I invite you to join the Renaissance. So thank you. Before we switch it over to David, just a quick reminder that if you have questions, please enter them in the chat box, and we'll be answering them all at the end. David?
Thank you, Bill. Just to reiterate, my name is David Breeding, and I'm the Director of Analytics here at AppGeo, but I also lead our product teams here, and we've been investing effort over the past few years in developing a solution called Giza to deliver imagery. But what I want to talk about today, just some considerations and the methods associated with delivering imagery content to end users, and so a few thoughts on how we can, potentially improve those delivery activities. Starting with the fact that in this world now where imagery is more pervasive, and it's critical that performance is there to meet those expectations. No longer do we measure response really in kind of seconds, but sub-second kind of performance is what those users are really kind of seeking, and kind of similarly to Netflix and Spotify. Like I want it now, and I don't want any latency in that response. There's also the fact that imagery comes in a lot of shapes and forms. Over the years of collection, you probably have amassed a variety of products and created derivatives, and really kind of how do you kind of format your data so it's ready to be streamed or served at the pace required, and that it's also ready to answer the questions of the future and create some derivative products from that imagery. The other kind of consideration is how are we going to store this, and how do we access this data? Some of these graphs just show what's obvious when we think about techniques to serve imagery. Caching that imagery delivers some of the best performance. The imagery is ready to go, but there's definite considerations about how much are we, where are we going to store it? To what level are we going to cache it? How performant? What's the best mix to get the best performance? And this is something that must be considered, and we've worked hard to try and find a good balance when it comes to making sure you get the best of both worlds while managing cost. And from an access perspective, making sure that in the world of streaming kind of imagery products, or where imagery might have different terms of service, you want to be able to provision that imagery and have control over who has access, when they have access, and that shouldn't be tied to a seat count. That should be something that's inherently, that's easy to do and easy to kind of manage. but just to kind of think about it at a high level, like what's going on here, how is imagery being delivered, and oftentimes this kind of tiling approach is very common. It delivers some of the best performance, and you know, you have your source data, whether that's imagery or potentially, you know, vector data in the context of vector tiles. You're creating these tiles, and then there's a decision about, you know, caching. Where's that stored? How can we make that accessible? And then also, if we're not going to cache everything, how do we respond to those requests? And you know, the ideal solution is you have an endpoint. You have an imagery service endpoint that you can go to that is a common way to communicate with all of the various applications, whether it's in the cloud or in the web, or whether that's locally on, you know, in your desktop environment. And the streaming services are kind of that imagery service endpoint potentially, or it's your ArcGIS for server endpoint. That's that element in this kind of you know, in this diagram here, which can take a variety of forms and have a variety of different features that you can leverage. When we thought about creating kind of the Giza product, we also were thinking about what else can we do, you know, in addition to getting it right, in addition to having performance service, in addition to leveraging all of what the cloud has to offer. But you know, we thought about the value of the actual usage, that content as it streams in and out. You know, what could we learn from that? How could you, if you knew who and when and where that tiling kind of content was being presented, could we be smarter about how much we're tiling, or plan our tiling better, kind of, you know, manage that cost as far as the storage is concerned? Would we understand better how our users are actually leveraging this content, uncover new use cases, expose that to those that are really interested in the program or responsible for funding it? You know, if we just had that content, you know, that would be a real value. And then finally, some of our kind of partners in this imagery serving kind of prospect have been using that metadata to really try to share costs more effectively among those users that have a vested interest in the success, availability, and you know, quality of imagery content. You know, Giza was the product that we developed to try and really execute on that, to make sure that you know, your imagery solution would scale, to use the efficiencies of the cloud to reduce costs, to store and make available that reporting data so that you can make more intelligent decisions about how to buy, where to focus your attention using data-driven kind of metrics. And then also, you know, Giza provides that access, that level of granularity that many organizations require, to one, make sure it's easy to get access to what people or what individual users are provisioned, but also control that kind of flow and remove, you know, those credentials when necessary. And again, just to hit on it, that kind of idea that you could potentially share costs more effectively with some reporting data, and Giza can kind of do that at scale and has been effective. But happy to chat more about anything and during our Q&A period. But at this point, I want to switch it over to Jarlath and let him kind of talk a little bit about some of the derivative products and things, what you can do with imagery today and the technology that's available.
Wonderful. Thank you, David, and good afternoon, everyone. I don't have really as cool a title as Bill, but I'll just venture to put it out there that perhaps I've got better facial hair. So what I do and what my group does is really go from data to generating information. And we spend a lot of time taking all this great remotely sensed data out there and turning it into land cover products so that people can integrate it into their GIS and help make better decisions. So one of the projects that we've worked on with AppGeo recently was generating high-resolution land cover for the city of New York. It's an extremely challenging and heterogeneous landscape, but with wonderful overhead remotely sensed data. And our job is to take that remotely sensed data and turn it into detailed, thematic land cover data sets that the city can use for a variety of planning and environmental analysis purposes. We've also worked in challenging arid landscapes. This is from a project out in Los Angeles, once again taking their imagery, fusing it with LiDAR data, and applying cutting-edge automated feature extraction algorithms to derive high-resolution land cover products. So as Bill and David have talked about, we're awash with data right now. We've got tons and tons of remotely sensed data out there. And we're also seeing this explosion of new technology, and a lot of you have probably heard about different remote sensing techniques for extracting imagery, whether it's machine learning or object-based feature analysis, all this stuff that's out there. And you may be slightly confused, bewildered, or just overwhelmed by it. And a lot of the focus right now seems to be on speed. You see this on tweets, people talking about analyzing satellite imagery for the entirety of the US and how fast they can process it. And you may think that this is new, but the truth is that we've been here before. And when the first original Landsat satellite was launched, we moved into the era of digital remote sensing. And instead of using manual interpretation, we used machines to try to extract information from those data. And for a long time, critics have looked at those products, like Chuck Olson, who wrote up the Elements of Image Interpretation, which we all learned in Remote Sensing 101, and have said that, perhaps the accuracy isn't quite there yet for these products. That was true then, and that's still true now. So as you think about turning your remotely sensed data from data to information, you're often given a choice between, do we go the old manual interpretation route? And a lot of you are involved in products where heads-up digitizing, stereo compilation are still used to derive products like planimetrics, curve edges, all these types of things, or to go automated feature extraction, whether it's traditional pixel-based technologies, object-based image analysis, or some of the new artificial intelligence algorithms that are out there. In most cases, you're probably going to want to employ a hybrid approach going forward, where we can leverage the advantages of these new advanced technologies, but at the same time also ensure that a human is looking at these data to ensure that they meet their standards. And regardless of your approach, you still need to back off and think, why are we doing this? What are our specifications, especially with respect to the end user community, and think about how we're going to update this going forward. If we just get wrapped up in the latest algorithm that's the latest publication or the latest tweet, we're going to miss the mark in all three of these areas. And we've also got to keep in mind that in many cases, it's not just the remotely sensed data we have access to. I think all of you are living in areas where if I asked you what's your collection of data, you would list dozens or perhaps even hundreds of layers of existing mapped features. And we can incorporate those data sets intelligently with our remotely sensed data to derive information faster, more accurately, and ensure consistency between time periods. So let's just take a look at an example at how integrating remotely sensed data helps us. This is from an arid environment, and we can see here the impervious features and some of the natural landscape, those bare soil, spectrally are very similarly. But if we can incorporate LiDAR data, specifically a slope model from a digital elevation data set, we see that those impervious areas have been graded and thus appear very, very smooth. And thus by fusing these together, we can generate high quality, high resolution land cover products. An example of an AppGeo project that we did in the state of New Jersey that substantially reduced their costs of deriving road data was to take their existing road center lines, which were in excellent condition, integrate it with their image data sets, and to build an automated algorithm that extracted road polygons for the entirety of the state. In this case, the state did not need curb edge planimetric quality data, but they were happy to sacrifice a little bit of accuracy in order to derive a product that could be generated at 1/30 of the cost as it would to do traditional heads-up digitizing. An example of how we can also integrate data to help us make more intelligent decisions about the features is mapping chicken coops. And this is a project that was done to look at agricultural impacts for a watershed. Chicken coops appear similar to other industrial storage facilities on the landscape, but when we can combine imagery with LiDAR data and then integrate the parcel data, we can make more intelligent systems in our automated feature extraction algorithms that accurately and effectively delineate those things. This allows us to take care of 98% of the mapping, allowing them final manual QA/QC routine to address only of those issues where the classification may have been problematic. In our AppGeo product in the city of New York, one of the things we identified very early on that we needed to do for our land cover mapping was to update the buildings layer. If you've been to New York City recently, you've probably seen that there's an awful lot of construction going on. Now, New York City had an excellent buildings layer, so we didn't need to unleash some type of fancy machine learning algorithm across the entire city. Furthermore, the city really wanted to ensure that the new buildings that were going to be derived from the updated remotely sensed data were consistent in terms of quality with their existing building footprints which had been derived from traditional heads-up digitizing. So we took the imagery and the LiDAR data, incorporated their existing building footprints, which as you can see here are a little bit outdated for this area. We've got a new building, and if you look closely next to that new building, you'll also notice got a couple of buildings that have been removed. And then we built an automated system relying on all three of these data sets, the imagery, the LiDAR, and the existing vector data, to identify those buildings that had been added since the last release of the vector polygon data, and also those buildings that had been removed. Now, the automated system did a great job of finding these, but the quality of those features wasn't matching that of the existing building footprints. So rather than try to build some sort of fancy automated system, we realized that there were only a few hundred updates, and thus what we could do was take into account the location of all of these, spit those out to a point feature class, and this allowed the manual interpretation team to go through using the same established procedures and update the buildings. The city had a clear understanding of what had changed, and our algorithms were designed to ensure that we overshot the mark a little bit, meaning that we identified more features that had changed than actually had, because it's easier for an interpreter to ignore a false positive than it is to find that building that we had missed. And regardless of the type of remotely sensed data that you have, as Bill mentioned, going forward, we're always going to see specifications improved. So this is zoomed in to a LiDAR point cloud for a project we have going on in Chicago. This is the original LiDAR data set. This is the new LiDAR data set. You can see here we've moved from QL3 LiDAR data to really a type of QL0 product in which we're over 20 points per square meter. You may think it's better to use these new products to extract and map these features, but when we overlay them on each other, with the green points being the original LiDAR data and the magenta points being the new LiDAR data, we see that the difference in standards can actually make it very, very difficult to determine what has changed and what has stayed the same. We see over on the right there that that large tree seems to have been removed, but the other features have been there all along, and we can't just do straight up differencing to determine whether it's changed or not. And so our machine learning algorithms are really, really good at extracting information from something at a single point in time. But what we see right now is they perform exceptionally poorly when we integrate data from multiple time periods or when our data specifications change going forward. And in New York City, we had to tackle this head on, not only for the buildings, but also mapping tree canopy change to assess the impact of New York City's A Million Tree initiative at the same time where the city had faced insect outbreaks and major storm damage to its urban forest. So here's the imagery from the first time period, the second time period, the LiDAR data from the first time period, and the LiDAR data from the second time period. These data sets acquired at different times by different contractors with differing standards. Our challenge here was to build an automated system that could detect these changes, reduce the variation that was due to the differences in the data sets, and capitalize on the efficiencies in machine learning and automated feature extraction in order to reduce the load of the manual interpretation team. The majority of the cost on this project was still manual interpretation, but by leveraging automated feature extraction technologies, that cost was about 1/15 of what it would be if we just did manual interpretation alone. So coming back to the three things, keep in mind why you want to extract the information from the imagery, right? Maybe you just need your imagery as a backdrop, and that's fine. Think about those specifications, right? If you require those high accuracy products, you may want to continue to stick with planimetric updates. However, if you're willing to sacrifice a little bit of accuracy and quality, there's some wonderful techniques out there, particularly leveraging automated feature extraction technology that can save you a lot of money. And then finally, keep in mind that going forward, maintaining that data to ensure that you can consistently track the changes in your buildings, the changes in your tree canopy, the changes in your impervious surfaces can be very, very challenging as those data specifications alter over time. So thanks, everyone. Enjoy hearing whatever questions you may have.
All right, we see only one question in the chat room so far. It's about, I think everybody can see this because it's presented to everyone, about with the retirement of the free NAEP program, will imagery content programs then negotiate the cost of replacement product at a state and or local government client level? I don't want to pretend to speak authoritatively about NAEP, but I do expect that the imagery content companies are really good at recognizing market opportunities, and will be very happy to propose solutions to fill that gap. I do see that we have Randy Maiden from Hexagon on the webinar today. Randy, I could unmute you if you have anything to add there. If you don't, that's fine. But I'm gonna go ahead and unmute you.
No, I don't think so. I think that the NAEP program obviously is going through some growth and trying to determine where that program will eventually end up. So I really, I can't speak for NAEP either, but I think it's fair to say that the program is continuing to move forward, but there are probably changes in store for all of us.
Thank you. Bridget, do we have other questions that have come just to you?
No, just the one that you answered.
All right. Well, we are happy to take more questions. Please get them in the chat box if you have any questions at all.
And everyone should have the ability to unmute themselves now if there's anything you'd like to speak aloud.
Anything? This was I know a lot of material, but there must be other questions out there. Fire away.
All right, I'll go. This is Michelle Giorgiani from AppGeo. You guys know me, and of course I have a question. So I was just thinking about Jarlath's what he was saying about, it's really important to have consistent products from year to year in order to be able to do the image interpretation and produce products that you can compare against each other from year to year. Can you guys speak to that at all as far as the new content imagery program goes, with it growing so much and changing so much? What do you think are the likely chances of the specs staying the same year to year for that type of analysis?
Well, I'm happy to take a crack at that since I brought it up, Michelle. So this is Jarlath, and I think we just need to accept that the specs are going to change. We're going to have better LiDAR, we're going to have better imagery. But what we do need to keep in mind is that as we map from these better data sets, let's just take impervious surfaces, for example. Let's say we've been traditionally mapping from 1 meter NAEP, and then we move to a 15 centimeter hexagon product. We're going to detect more impervious surfaces. And we have to be very careful as our algorithms improve and as our data improve, is that we don't always say that this change is due to actual new features, but rather it's due to our ability to better detect these things. And I think we're going to see organizations spending a lot of time and resources trying to resolve differences in their data set, particularly things like impervious surfaces. They may be under mandates from the EPA or another government agency to track consistently over time. So this is going to be quite challenging, I think, for a lot of people. We all want better data, but with better data comes new opportunities and new challenges.
And just to jump on the end of that comment, try to address that question. When you think about procuring some of these streaming products that are out there, that is another differentiator to consider. How consistent or how focused are the providers in ensuring that when they're doing their collection year to year, that they're doing their best to kind of maintain that spec, to make sure that those lines are as close as possible, so that when you do, when you eventually want to kind of maybe do that comparison work, that you hopefully can minimize to the degree possible the amount of differences that you have to handle. But to Jarlath's point, there's going to be differences. It's just how much you need to address and how much effort you might have to apply to control for that variation.
Okay, thank you. So I see some other questions here popping up. There's one here from Aaron. Any comments on what is next after 15 centimeter? In the Hexagon program, there's also something called the City Mapper, which is going to be producing some additional products in urban areas. And I don't actually have the details on that And I'm going to ask Randy Maiden if he would like to say anything on this one.
Yeah, Bill. The City Mapper is a sensor that was developed by Leica, and it simultaneously captures 5 centimeter nadir imagery, oblique, and also LiDAR data. That technology will be incorporated into the new content program as we move forward. Eventually, it will replace what was typically the 15 centimeter in what we called our urban area collects. So again, we're just taking the technology, improving upon that, and making more and better data sets available.
Okay, thank you, Randy. We have one here from Jay Giles. What is the near map default GSD? I actually don't know the answer to that. We don't represent near map, and I don't have their technical specs in front of me, but I'm sure they would be happy to have a conversation with you about that.
Just before you move on, Bill, we did a mass on our website. We did an imagery kind of comparison. There's a piece of content there that I'm not sure if it has the GSD specifics, but we can, there is some content that we've developed that try to do some compare and contrast of the various providers in the market space.
Right, thank you. Yeah. Okay, Zara Khan is asking which applications or use cases are you seeing for which content programs are most suitable? We really think for the majority of the typical imagery use cases, as a background layer for your vectors, to kind of verify, geocoding results or point features that you have in your data set to understand the context. So when you're looking at some location data, do you know, are you in a wetland area? Are you in the forest? Are you in the open? Are you in an area of homes and that sort of thing? Those are ideal. Where the content programs are kind of at their edges is for the very sophisticated kinds of feature extraction things where you might be bumping up against a derivative products language, in which case those are things you definitely want to be talking about with the content provider at the outset to make sure that you can get the items you need, whether it be the fourth band or the ability to extract derivative products and those sorts of things. This, in my opinion, there's a lot of flexibility in the providers to accommodate that, but you need to have those conversations and need to negotiate those terms if they're not already covered in the kind of the standard contract language. David or Jarlath, anything to add there?
When you're considering, doing feature extraction and kind of, or some of the ML processes that are potentially out there, having access to that raw imagery is really kind of required from a processing speed perspective. Streaming that in from a service. I actually haven't seen an example of, out there where you're not working with the underlying data. However, it's not technically impossible to do that. But Jarlath, I don't know if you often work with a raw imagery product, correct, when you're doing your processing work?
Yeah, that's right. And it really depends on the type of features that you're extracting. And this can get challenging because in some cases, buildings, you can chip this stuff up into these tiny little images that shove into the GPU side processing. And other times you need broader extent. And you may want the raw sort of, quote unquote, raw files in GeoTIFF format, and sometimes proprietary formats, especially things like Mr. SID, can actually really impact your ability to do automated feature extraction going forward. So those are definitely considerations.
But as Bill said, that's something to negotiate, with the streaming service, and make sure that you really evaluate what you're trying to do. That slide that Jarlath had about kind of defining what your goals are will really kind of then dictate what terms you need from the streaming providers.
Yeah, I see Pete Reed from the Census Bureau has his hand up. Pete, you have a question?
Actually, as a comment, going back to the NAEP question, just got a message from USDA. There is currently no planned program strategy to remove the NAEP dataset from public domain. Okay, just to share with everybody.
I appreciate that. Thank you. All right, and then we have a couple more questions on the chat. Eric Hund is saying, public depends on access to free imagery provided by the government. This access would go away if the government moved to an imagery content licensed approach. Eric, I think I'd end up repeating some of what I said during the webinar, but I think we have to distinguish between access and ability to use the imagery versus download, and it becomes a value trade-off. How much is it worth to have that download, and are you willing to accept any compromises such as a resampled lower resolution version to meet that free download requirement, and or an older version? And I think it's worth, that's a philosophical debate that's worth having, because the savings are so substantial in a content program that I think it really does beg that question about, is a download worth, paying twice as much for the product? And let's have that debate. Let's have those conversations.
Just to jump onto in the context of download, when we think, Giza as a platform has some limited download capability, and we heard that during development that this was critical, that it needs to be in there, and we built it. But when we look at the metadata and the stats about how many people are actually downloading the data, we are often finding that it was either an individual with a very specific workflow that was using it, again, in the confines of that state agency, as compared to the majority of users just really needing that access and weren't downloading. Again, there's always going to be those use cases which require it, but that trade-off, and do you have data that can help support or that argument to really go out and make your case for it? I guess that would be my thought process there.
All right, we do have a question here from Jay Giles. Is the hexagon imagery 3-band or 4? It's an easy one, it's 4-band. You do get the IR band with the hexagon. Do we have any additional questions?
Bill, this is Joe. If I'm wondering, since Hexagon's on, I think one interesting product that I've seen them producing from the NAPE is we're seeing the emergence or re-emergence, perhaps, of photogrammetric data and point clouds produced from the imagery. And as our imagery becomes higher resolution and the automated techniques for extracting point clouds from imagery come out, I think people will be pretty impressed to see what can be done with what people are calling, FODAR, photogrammetric LiDAR point clouds, and that these can be a really nice addition to your elevation data sets, particularly when you're going perhaps over a decade between LiDAR products.
Okay, thank you. Any other questions? I'm just scanning the attendee roster here. I don't see any hands up at this point. I guess I'll say last call for questions. Anything else? All right, well, we're at 58 minutes, which clocks out very nicely. So we thank everyone for attending today. And at this point, we will close out. Thank you.
Thank you very much, everyone.